Hello, each and everyone. Today we are going to discuss about the real numbers, chapter 1, class 10th, and we will complete this chapter in 4 videos. So first we are taking. So first is the introduction. So real numbers. Real numbers. If we talk about the real numbers is the real numbers are the collection of rational and irrational numbers. So real numbers are the collection of rational and irrational numbers. But before to understand the rational and irrational, few more things we would like to discuss. So look at here now. These are the few notations are there, like n is natural numbers. Natural number means the counting numbers are known as natural numbers. Integers are denoted by z, capital Z, or sometimes by the I. Integers are divided into the two parts, maybe the positive integer or the negative integer. Positive integer denoted by z plus, then you can say plus 1, plus 2, plus 3, likewise these are the positive integers. And z minus means negative integers, minus 1, minus 2, minus 3, likewise these are the negative integers. You can say these are negative integers and these are positive integers. Then C is the complex number. Complex numbers are denoted by the C, real numbers are denoted by the R. Q represent the rational numbers, W whole numbers, and irrational numbers in few books it will be given like T. They are representing by the T, capital T, or R backslash Q. It means this one means what? It means R backslash Q means all the real numbers. From the all real numbers, if we take out all the rational, you will get the irrational numbers. So these few things is already you know that. But to refresh your memory, we discuss. Now the rational number, in short we are going to discuss rational number, you know, then if P and Q are integers, then can be written like Q over Q in the form of the fraction, where denominator is not equal to 0, then you can say this number is a rational, like 1 over 2 is rational, minus 3 over 2 is rational, 5 over 6 is rational, all these are the rational. And if we talk about the irrational numbers, the number which cannot be expressed exactly, cannot be expressed exactly, they are known as a irrational numbers. Or sometimes we are saying the number which is not a rational will be the irrational. For instance, like root 2, root 3, root 5. These all are the irrational numbers. So irrational numbers you can say the number which cannot be expressed exactly are the irrational numbers. Rational, the number P and Q are the integers, but they can be written in the form of the fraction. The number should not be equal to 0. Then you can say these are the rational. Now which numbers are not the rational? For instance, you are taking like 1 over 0, 2 over 0 are not rational numbers. Rational numbers. So these are the few things which you must know. And next we will discuss the eclipse division lemma. Okay. Now the eclipse division lemma. What is eclipse division lemma? But before to understand this one only, we will discuss about the lemma. Lemma means what? So look at here. Lemma. A lemma is a proven statement used for proving another statement. Lemma is nothing else, it is the proven statements, and that statement we use for to prove the another statement. But here is, first of all, we will discuss the statement means what. Is already you know the sentence. Sentence means that is the collection of words which have a meaning. But any sentence is changed into a statement if it is either true or false. Any sentence will change into the statement either should be true or false. For instance, you are saying like we are saying 2 divides 10. So this is a true statement. 3 divides 5 is a false. So this is a, you can say this is a statement is there, and this is also the statement. But remember, every sentence is not a statement. For instance, you are saying God bless you. God bless you is not a statement. So lemma is nothing else. It is a proved statement which is used for proving another statement. You can say, let's suppose A is the statement to prove the statement, but with the help of this A, we are going to prove the another statement B. Then you can say this is your lemma. So lemma is nothing else. It is a proven statement used for proving another statement. Now algorithm. An algorithm is a series of well-defined steps. Well-defined means understandable. It should be understandable. Means that whatever the steps you are writing in a series, which gives a procedure for solving a type of problem, which is known as an algorithm. So with the help of the series of well-defined steps, we are getting the procedure for solving a type of problems is known as an algorithm. So sometimes the question is asked based on like lemma and algorithm. They can ask define a lemma, define an algorithm is their knowledge. So you must know the lemma and the algorithm. This is. Now let us come to the point. What is Euclid's division lemma? So the definition of the Euclid's division lemma is right here now. See. So the definition is giving positive integers a and b. A and b are positive integers. There exist unique integers q and r. Q and r are the unique integers, and these four a, b, and these unique integers q and r going to satisfy this condition. That is, a is equal to bq plus r, and this r must be less than this b, but greater than equal to 0. Then this is known as a Euclid's division lemma. So a and b are the two positive integers, but there exist unique integers q and r, and these four integers are going to satisfy this condition. Then you can say this a is equal to bq plus r, but this r must be less than. So if we talk about this statement like a is equal to bq plus r, in general if you will see, then what is this a? A is nothing else, it is your dividend. B is your divisor, and q is your quotient, and r is your remainder. And this is very, very important. You know, the remainder, if you are going to divide any number by a divisor, then you will see, you will continue this process till the remainders either comes 0 or less than this divisor is there. So r is less than b or greater than equal to 0. So there is a relation in r and b. You should be very careful, because sometimes they can ask in a question, what is the relation in r and b? So instead of this one, like this concept I am taking, they are, instead of the a is equal to bq plus r, they are going to write p is equal to nq plus s. Then they can ask what is the relation in this one. So here is this s at the place of remainder and m at the place of the divisor. So what will be here? S will be less than this m, but greater than equal to 0. You are not supposed to change the place of this m and q. For instance, suppose s is equal to qt plus n is given. Then this q at the place of the divisor. So at this n at the place of the remainder. So here the relation will be n is less than q, but greater than equal to 0. So Euclid division lemma means any two positive integers, and there exist the q and r, the unique integers which are going to satisfy this condition, that is known as a Euclid's division lemma. And now we will discuss the use of this Euclid's division lemma. Okay. Now we will discuss then to obtain the SCF of two positive integers. How can you find out the SCF of any two positive integers? But before that, you must keep in mind these two concepts. Number one is here, Euclid division lemma, and algorithm are so closely interlinked that people often call former as the division algorithm also. Second step is here, although equal division algorithm is stated for only positive integers, only for the positive integers, and it can be extended for all integers except 0. Means, you know, this is a is equal to bq plus r, and then the relation r is less than b is equal to 0, but this b is not equal to 0. This b is not equal to 0. So these are the two concepts are there. Now we will discuss that how can you find out the SCF of the two positive integers. First, let's suppose the numbers are given 12 and 30. These two numbers are given, and you want to find out the SCF. SCF means is already you know that is highest common factor. So to find the SCF of any two positive integers, positive numbers, we have two different methods. One is the prime factorization method. Prime factorization method. And second is long division method. There are the two methods are there by which we can find out the SCF of these two numbers. First one is by the prime factorization method, just by doing the factors of these two numbers by prime factorization method, and second is the long division method. So this long division method is just equivalent to the question can be asked you to find out the SCF of these two numbers by using Euclid's division algorithm. So that long division method is nothing else, that is the just equivalent to this Euclid's division algorithm. So here I will take the two numbers and we will try to find out the SCF of these two numbers by the Euclid's division lemma. Okay. Now question we are taking. Question is use Euclid division algorithm to find the SCF of these two positive integers. See now. So by using this Euclid division algorithm means that is the long division method is here. So for the own convenience, roughly you are supposed to do here first. See, because you know this is Euclid division lemma is a equal to bq plus r, that is already we discussed. Then r is less than b, but is greater than equal to 0. So this b is your divisor, is already we discussed. And q is your quotient, r is your remainder, and a is your divisor. This is already we discussed. See now. So roughly you are supposed to do here only by the long division method that we are supposed to note down here. So just these two numbers are there. This is the way. So by the smaller number you are supposed to divide the greater number, that is 225. So you must divide this 225 by 135. So you will divide 135 on 135. So here you will get remainder is 0. Here is 5 minus 5. 0 is here, and here you will get is 9. So 90 is your remainder. Now by this remainder, again you must divide this divisor. And we will continue this process until unless the remainder comes 0. So we will divide by 90 is this one. So 91 are 90, and here you will get 45. Now this by 45, you will divide this number again. 45, 2s are 90, and you are getting 0. As you get the zeros here, this number, this is the divisor is here, will be your SCF. So your SCF is this one. So we are supposed to divide by the smaller number to greater the number, and we will continue this process until unless your remainder comes 0. So here is finally, if we write in the form of this one, then first step we will write here 135 is equal to this, 225 is equal to 135 divisor into quotient into 1 plus remainder is 90. So this is your one step. Second you will get from here, that is 135 is equal to 90 into 1 plus remainder, this is 45. Third you are getting from here, this 90 is equal to 45 into 2 plus remainder 0. So here, as the remainder comes 0, your this divisor, last divisor will be your SCF. So SCF is equal to 45. But this is the roughly we are doing for the own convenience. But as you will write for the this one use equivalent division algorithm, you will write the algorithm is here only. Then the way of the writing the algorithm is solution. You must write down here is step 1 first. Step 1. You must write down the step 1. Step 1. Now in these two numbers, just this is the way of the writing. Since 225 is given then 135, we apply division lemma to 135 and 225 to get. So this is the dividend. If you divide it plus remainder, you must note down here. Now in second step, you must write down here the remainder. This is your remainder. The remainder 90 is not equal to 0. So we apply same ways here. Apply the division lemma to 135 and 90. 135 and 90 to get this second one we will write here. So 135 is equal to 90 into 1 plus 45. Likewise we will repeat this one. So in third step, now in step 3, here is C, look at here, 45 is not. So in step 3 we will write the remainder 45 is not equal to 0. Same, like we write, we apply the division lemma to 90 and 45 to get. So 90 is equal to 45 into 2 plus 0. So now here is your remainder is coming 0. So then you can say then the remainder is 0. So our procedure is stopped. And the procedure is going to stop. The last divisor will be your SCF. So therefore, SCF of these two numbers is 45. And this is your answer. So this, while using the question is saying equivalent division algorithm. So equivalent division algorithm is nothing else. It is just the long division method is there. By the long division method, roughly we are supposed to do, and thus then write down the dividend is equal to divided 2 plus remainder, and we will continue this process until unless your remainder comes 0. As your remainder comes 0, the last divisor will be your SCF. Is SCF. So this is your answer. Okay, children. Now this is the question from your NCERT book. NCERT. First exercise, question number 3. This is your question number 3. See, the question is 3. He's saying the question is use Euclid's division lemma to show that the square of any positive integer. If you are going to do the square of any positive integer is either of the form 3m or 3m plus 1 for some integer m. So we will try to answer the question first. What the person is saying? He is saying square of any positive integer. Any positive integer you are taking. Suppose you are taking 2. You are going to do the square of this number 2, that is 4, and 3, 4, 5, like that you can take. What the question is saying? The question is saying if we are going to do a square of any positive integer, that can be written in the form of either the 3m or 3m plus 1. 3m or 3m plus 1 means what? If that can be written as in the multiple of 3 or multiple of 3 plus 1. For instance, look at it now. Suppose you are taking 2. 2 square you are doing, square of this number, you are writing 4. So this can be written as 3 into 1 plus 1. This is just equivalent to 3m plus 1. What is m? M is 1. So the square of any number can be written either in the form of this and this one only. Like 3 square, that is 9. So this can be written as 3 into 3. So this is like 3m. So here is m is 3.
4 square, that is 16. So this can be written as 3 into 5 plus 1. So m is your 5. And 25 is here, so this can be written as 3 into 8 plus 1. So m is 8 is here. So what the person is saying, if you are going to do the square of any positive integer, that positive integer can be expressed either in the form of multiple of 3 or multiple of 3 plus 1. That we are supposed to show that is here. So okay, now the solution is, so let x be any positive integers, that is can be replaced like x is equal to b. B is nothing else, this is 3. 3q plus r, where r is less than this 3 but greater than equal to 0. See, remember, in equality division lemma is already discussed, a is equal to bq plus r. This is your divisor. We want to write in the form of multiple of 3. So this 3 is working as a here as a divisor here. This b is 3 is here. You know, so from here only you come to know then what will be the value of b is here. So b is 3 is here. So x is equal to 3q plus r, where this r is always less than this 3 but greater than equal to 0. So therefore, what you will get? Therefore, what will be the value of r? R is greater than equal to 0, so it is 0, 1 and 2. So r will be equal to 0, 1 and 2. So r is 0, 1 and 2. Then what will be the x? Therefore, x will be equal to, just put r equal to 0 is here. You will get x equal to 3q. R equal to 1, so that is 3q plus 1 and 3q plus 2. So now we are getting in general x is equal to these are. Now we will check for these three numbers. If you are going to do the square of these numbers, they can be written in the form of multiple of 3 or multiple of 3 and plus 1. So just take the case 1. Case first I am taking. Case 1 is there. If x is equal to 3q we are taking, so you must do the square. X square is equal to, you will do the square of this one, 3q square, so that is equal to 9q square. But this 9q square can be written as 3 into 3q square, and you can assume that 3q square is equal to m, so this is equal to what? That is 3m. So this x equal to 3q can be written in the multiple of 3. Similarly, we will check for this 3q plus 1, whether this can be written either in the form of 3m or the 3m plus 1. 3m is multiple of 3 or multiple of 3 plus 1. So now the second is there. So if x is equal to 3q plus 1, so we will do the square of this one. X square is equal to 3q plus 1 whole square is equal to, you must expand this one first. So a plus b whole square, direct I will include. So this is 9q square plus 1 plus 6q. But this can be written as here only from 9q square plus 6q, we must write down together. Here you can take the 3 common from here. So this is 3q square plus 2q plus 1. And this is nothing else, you can assume that m is equal to 3q square plus 2q. So this is equal to 3m plus 1. So the square of this one can also be written in the form of 3m plus 1, multiple of 3 plus 1. Similarly, we will take the case 3. So now case 3, if x is equal to 3q plus 2, we will do the square. X square is equal to 3q plus 2 whole square. So a plus b whole square we will expand. So that is 9q square plus 4 plus 12q. Now here is there, you are supposed to very careful here only, because we want to write this either in the form of multiple of 3 or multiple of 3 plus 1. So you are supposed to expand this one. So this can be written as 9q square plus 12q, and you can break this 4. 4 can be written as 3 plus 1. First 3 terms, you can take out the 3 is common. So here you will get 3q square plus 4q plus 1 and this plus 1. You can assume this is m. Let 3q square plus 4q plus 1 is equal to m. So this is equal to 3m plus 1. So finally what we are getting? It means you can say therefore the square of any positive integer is either of the form